Assalamu alaikum warahmatullahi wabarakatuh. In today's class, we will be going over some basic questions of moles. These will be extremely basic and we will only be using the formula and some new concepts. Otherwise, the difficult and intermediate questions of that chapter will be discussed in a later video in much more detail. This is just to get your grounds in the topic and understand how we use the formula step by step. Now, the very first question is basically asking us to figure out how many moles of sodium are present in 22 grams of sodium. And the formula that we will use here is basically moles is equals to the mass upon the MR. Now, the MR of sodium is approximately speaking 22 to 23. It is around about 23, so let's write it as that. So 22 grams of sodium upon 22 or 23 atomic mass unit of sodium. This will give us the answer in moles, and that will be, let me just confirm, 123. That will be approximately speaking 0.956 moles. Now I need you to keep in mind that this does not mean that we're talking about 0.9 atom of sodium. No, we're talking about 0.956 moles of sodium. That means, if you recall what a single mole means 6.02 times 10 to the power of 23 particles. Then by multiplying it with 0.956, now you will get the actual number of particles that are present in sodium. This is just the amount of moles of sodium that we figured out. Let's move on to another question. How many moles of water are in 44 grams of H2O? All right. So again, we will be going over it step by step. The moles of water would be equal to 44 grams in mass of water upon the MR, or the molecular mass of water, and that can be calculated by just counting how many atoms and what atoms are present. So we have one hydrogen and we have two oxygen. The mass of a hydrogen is 1 and the mass of an oxygen is 16. Oh sorry, we have two hydrogen and one oxygen. Now this is correct, and we will get two atomic mass coming from the two hydrogens and one atomic mass unit from the one oxygen. In total we can get 18 atomic mass unit of H2O. So now we will divide that with that and we will get the amount of moles, and the answer will be 2.44 moles of H2. Now the second part is interesting. The second part is saying how many moles of oxygen and hydrogen are in 44 grams of H2O. So it's asking the same thing, but it's asking for the amount of oxygen and hydrogen atoms that are present. So that means that, and the wording wouldn't be atoms, because now we're not talking about the amount of atoms, we're talking about the moles of atom, how many moles of atoms are present in H2O. So if we want to figure that out, perhaps we can use the equation. We know that there are 2.4 moles of H2O, right? This entire particle is 2.4 moles, 2.44 moles present. So if we divide this into two particles, if we say that what and how many atoms are made or making this amount of H2O, then we will get two hydrogens and one oxygen. So basically, that means that if we're talking about a single particle of H2O, then that single particle will have two hydrogens and one oxygen. If we have 2.44 moles of water, then that means that we will have two times the amount for hydrogen, and that will give us 4.88 moles of hydrogen that is present in H2O of that amount. And 1 times 2.44 will give us again 2.44 moles of oxygen that is present in H2O. So we just broke it apart into two things and got the answer as such. One particle has 2.44 moles, so that means that if we break it down into the atoms, then one particle has two hydrogen atoms. And that means that 2 times 2.44, we will get 4.88 moles of hydrogen, and for oxygen it will be 1 times 2.44, and we will get 2.44 moles of oxygen. So this is how you will answer that question. Let's continue onwards and see what else is in store for us. The equation for the burning of hydrogen and oxygen is shown. This equation is basically showing us a simple reaction in which hydrogen is reacted with oxygen, or it is burnt in oxygen, giving us water. What does this equation indicate? That's the question. So two atoms of hydrogen combine with two atoms of oxygen. That is incredibly false, because that is not the case. If we talk about hydrogen, or if we talk about water, then we will say that it has two hydrogens and one oxygen bonding together. So this is incredibly wrong. This is not the case. Question number, part number, sorry, 2 is saying 2 grams of hydrogen combined with 1 gram of oxygen. If we were to use this in terms of moles, then we will not get the correct answer. Keep in mind that the equation is telling us the amount in moles and not the amount in mass. Our mass is dependent on the amount of moles it has. So if we were to convert it into moles, let's see what we will get. So if we were to use this, then 2 grams upon 2, the reason why this is 2 is because one particle of hydrogen has two hydrogens, then that means that we will have 2 mr, we will get 1 mole of H2, all right, and 1 gram of oxygen. 1 gram of oxygen would be 1 gram divided by 16, which is the atomic mass of oxygen, and this will give us 1 upon 16, that is 0.0625. Now we need to reinforce, we need to confirm that is this a complete reaction. If it isn't, then this is not what this equation indicates. If we were to find the ratio of this, we will get 16:1 ratio. Matlab hydrogen and oxygen, H2 and O2 ratio is 16:1, and the equation is showing us the ratio of 2:1. So this is wrong as well. This cannot be the answer either. 2 moles of steam can be obtained from 0.5 moles of oxygen. Let's see if this is the case. Our equation will always tell us the ratio, and that ratio is of moles. If we have 1 mole of oxygen, this entire particle represents oxygen in normal environment. This entire particle represents oxygen gas in a normal condition and normal environment. Then that means that O2 with the ratio of H2O would be what? There is nothing written here for the space of oxygen, then that means that it represents 1. There is something written here and that is 2, then that means that 2 moles of water are made for every 1 mole of oxygen. Alright, so we get the ratio 1:2. So this is also not the answer. This last option is saying 2 moles of steam can be obtained from 1 mole of oxygen. We've just confirmed that that is the case, and that is indeed the answer. Let's move on to the next question. The next question is quite an interesting one. Let me just. Okay. So, what is the mass of oxygen contained in 72 grams of pure water? Now, this is something that I want you to try first, and then I will be solving it myself. This is something that you have gone through before. This is a question that you have seen before. So, first of all, you give it a try, and then we will solve it. Okay, so in order to solve this, we first need to figure out how many moles of pure water are there, right? Because we want to figure out how much moles of oxygen will there be, how much mass of oxygen will be there be in H2O. So we need to figure out that, right? So let's find how many moles of water are there. 72 grams of water is present and the MR of water is 18. How do we figure out it is 18? There are 2 hydrogens, then that means that 2 atomic mass unit, because 1 hydrogen has 1 atomic mass unit, and there are 2 of them, and we have 1 oxygen with 16 atomic mass unit. At the end of the day, if we add them all together, we will get 18. This will give us 72 upon 18, 4 moles of H2O was used and H2O was produced, and it is talking about 4 moles of H2O. Now, if we were to divide it into particles, and that means that this entire particle is 4 moles, and this entire particle has 1 oxygen atom present, then that means that 1 mole of, or 1 times the mole will be present in oxygen as well. 1 times 4, and that will be 4 moles of oxygen. Because this entire particle has 1 oxygen and we know that there are 4 moles of this entire particle, so that means that there will be 4 moles of oxygen present. Now let's use the formula once more and try to figure out the amount of oxygen that is present. Now we need to be careful as to how we're doing this and how we're calculating it, because we need to keep in mind what the atomic mass unit of oxygen is within this particle. Within this particle, the atomic mass unit would be 16, and then we will be able to figure out the mass, and that will end up being 4 times 16, and that is 64. So that is the answer. The mass, 64 grams. Let's continue onwards to the second last question, and that is this one right here. And these empirical formula questions are quite simple. First of all, let's get a simple understanding about what an empirical formula is. An empirical formula is the simplest ratio of the atoms present in a molecule. All right, it does not represent the molecular formula, it only represents the empirical formula. So for example, we have C2H4. This is not a simple ratio. We can simplify it further and we will get CH2, and this is the empirical formula. This is the molecular formula, the actual formula of the substance, and this is the empirical formula, that is the simplified version or the simple ratio of the atoms present. All right, so we can figure out the empirical formula from the percentage and the MR by themselves. So we can do it by using this formula itself. So nitrogen and oxygen are the ones that we're talking about, and we know that their percentage by mass is present in 47 percentage and 53 percentage, and this is percentage by mass. So that means that it is talking about the total mass, and that total mass has 47 percentage of that mass is of nitrogen and 53 percentage of that mass is of oxygen. So in order to figure out the simplest ratio, we can figure out the simplest ratios moles, and if we figure that out, we can get the answer. How do we figure the moles out? We figure that out by dividing it by MR, and the MR of nitrogen is 14 and the MR of oxygen is 16. We will get the answer, and that will be approximately speaking 3.35 or 36 with the ratio 53 upon 16, or 3.3125. If we round about them together, then we will get approximately speaking 3.3 is to ratio with 3.3. And at the end of the day, this we can further transform into an empirical formula. An empirical formula is simplest ratio in whole numbers. Keep that in mind. So it must be in whole numbers. So if you want to turn this into a whole number, you will get 1:1 ratio of nitrogen and oxygen present, and that is the answer right here. NO is the answer. So 1 nitrogen and 1 oxygen is the empirical formula of the substance we are talking about, of the nitrogen oxide that the data is telling us about, and hence this is the answer. Let's continue onwards and deal with this last question. A 10 centimeter cube sample of gaseous hydrocarbon is completely burnt in oxygen. The total volume of the product is 70 centimeter cube. All the gases volumes are made at room temperature and pressure. Now, in order to solve this question, you can go step by step and transform moles into the volume and go through it like that. It is quite simple to do it, but I will show you a shortcut. So 1 mole is 24 decimeter cubes. That is always a fact. So 1 mole of a gaseous gas in RTP, or room temperature pressure, is consuming 24 decimeter cube volume, always, forever and ever. You can do that step by step. You can convert this and you can figure out the moles and then figure out the equation of the moles and all that stuff. You can do that if you want, but that will be longer, and you have to conserve time in the MCQs paper so that you can get to the difficult questions and deal with those instead of these simpler ones. So I will show you a simple trick for you to solve this question, and that simple trick is that you always should keep in mind, you will not be using this for this time. You will be using a simple understanding that the ratio of volume is always equals to the ratio of moles. So basically, if you know what the volume is for each of the things, then perhaps you can find out the ratio of moles as well. But we absolutely do not have to, we do not necessarily need that understanding. So let's try to understand this furthermore. This is basically saying that 10 centimeter cube with the ratio of product. So if we're talking about the hydrocarbon, whatever that hydrocarbon will be, hydrocarbon, and if we talk about the mass or the volume, sorry, of the products, then we can figure it out in terms of ratios, and that will be 70 centimeter cube, and we convert that ratio into much more simpler form. We will get that 1:7 is the case, and as ratio of volume is equals to the ratio of moles, we can also say that 1 mole of the hydrocarbon creates 7 moles of products. So whichever equation satisfies this understanding, then that is your answer. And the equation that does satisfy this um understanding, let's keep that in mind. Let's find out which equation that would be. So here is our hydrocarbon. There is 1 mole of hydrocarbon there, there's 1 mole of hydrocarbon there, 1 mole of hydrocarbon there, and 2 moles of hydrocarbon right there. So let's now look at the products. There are 1, 2 and 3. So 1 from carbon dioxide, that is in gaseous form, and 2 moles of water, that is also in gaseous form. So in total this is 3 moles of gaseous product that is formed. All right, this is the 3 moles that is produced. So this is saying that 3 or 1 is to ratio 3 is for this first equation. Let's write it right here. 1 is to ratio 3. For B, it is 1 mole of the hydrocarbon, and 2 plus 2, that means 4 moles of products is made. So this is for the second option. The third, or option number C, is saying that 1 mole of my hydrocarbon is making 3 moles of carbon dioxide and 4 moles of water. In total 3 plus 4 is 7 moles. So this is the answer, as it is satisfying our equation, and that is hence the correct answer. All right, let's continue onwards and actually use that understanding that I just showed you. 1 mole is giving us 24 decimeter cube. We'll be using that understanding. We can also use it or convert it into the fact that there is 24 decimeter cube per mole. All right, this is a simple single value instead of writing this entire thing down. So let's try to figure that out. Sodium hydrogen carbonate decomposes on heating. In an experiment, 5 mole sample of sodium hydrogen carbonate is heated. This much of hydrogen carbonate is being heated. Which volume of carbon dioxide made at room temperature and pressure is evolved? So that is the question, and let's try to answer it. So if we were to find the ratio of the hydrogen carbonate, the sodium hydrogen carbonate, with the carbon dioxide, we will get that NaHCO3 with the ratio of CO2 is 2:1 from the balanced equation. This is what this is showing us. 2 moles of sodium hydrogen carbonate is producing 1 mole of carbon dioxide. So this is the ratio that we're getting. Now we know that we are using 5 moles of sodium hydrogen carbonate. We need to put 5 here, but we also need to keep the ratio the same. So how do we do that? The best and easiest trick is to make this, the thing that we have, into 1. How can we do that? By keeping a consistency. Let's divide both sides by the same number. Divide by 2 and divide by 2, we will get 1 is to ratio 1 upon 2, and then we can multiply this entire thing by 5. This will give us 5 moles of sodium hydrogen carbonate will give us 2.5 moles of carbon dioxide. So our consistency of 2:1 is still kept, except we just transformed it into the amount of moles that I wanted, or the amount of moles that the sodium hydrogen carbonate was consuming. So now that we've figured this out, we know that 2.5 moles of CO2 is right here, and we also know that 24 decimeter cube is produced every single mole. So in order to figure out the volume, we can use this formula. We can use 24 is equals to the volume that we need to figure out upon the moles, and this will give us 24 is equal to the volume upon 2.5, and this will give us the answer of volume, and that will be 24 times 2.5. It will be 60 decimeter cube. So 60 decimeter cube of 66 decimeter cube of carbon dioxide is produced after doing this entire thing. After 5 moles of sodium hydrogen carbonate has decomposed completely. So this is how you would solve simple mole question, and I hope you understood this entire understanding step by step. Any question that you have, feel free to comment down below or email me or contact me from my phone number. I will be more than happy to help you. And also keep in mind to subscribe and share this video to others as well. Inshallah it will help others as well. So मेरी तरफ से अल्लाह हाफिज़.